Hello everybody and welcome to Daedalus Plays with Electronics. Squiggly lines. We've all seen them. Sometimes you see them on the ground and sometimes you see them in the sky. But you don't usually see them on a circuit board. Well, not so much anymore anyway. It used to be more common back in the day. But nowadays usually they're all fairly straight and angular lines that you see on a circuit board. And that's of course because electronic components themselves are fairly straight. And if you've got anything that's got multiple legs like an IC, then those legs are usually spaced apart according to a certain standard. And that's why it makes sense to design your circuit boards on a grid, something like this, where every component can easily fit on there. Now, of course, we use computers to design circuit boards, and it just makes it much easier to work with straight lines and angles at 45 degrees, sometimes 90 degrees, doesn't really matter that much. And to work with curved lines or squiggly lines, that just adds a lot of complexity. Now that doesn't mean that it can't be done. I've got an example here of a circuit board that is designed with curved traces. So I thought it would be a good idea to try and design a circuit board completely by hand and just completely draw out all the traces and draw out exactly where I want all the components to go. So that's what I will be doing in this video. So now I just need to determine what I'm going to make. And I've sort of made up my mind. I'm going to make something that's fairly simple and is fairly easy to troubleshoot should it go wrong. And so I have decided to try and make an Atari Punk Console. Now, this is a fairly common device. You can find schematics for it anywhere online. You just have to Google for it and you will find dozens of examples. So I've taken one of these schematics and I've just drawn it out on a piece of paper here. And this is just for me to make sure I've got everything right and connected the way it should. And I've actually built it up on a breadboard here, so I can have a look at it, see how it works. Now it should be noted that all the schematics that you will find for Atari Punk Console will sort of look like this. And they'll have a 9 volts power supply going through a variable resistor or a pot meter, and then from there going into a 555 timer, or in this case a 556 timer. 556 timer is basically two 555 timers in one package, and you need two to make an Atari Punk Console. But there's one important flaw that you need to notice. When you dial the pot meter all the way to one end, then you run the risk of basically shorting out your power rail. So you've got 9 volts going through the pot meter straight into the chip, and this leg of the chip can actually sink current. So if you dial the pot meter all the way to the left or all the way to the right, then you can essentially short out your power supply through your pot meter and through your 555 timer, and that can damage both of those components, or could even just damage your power supply. So a common solution to that problem is to add a 330 ohms resistor in between your pot meter and your IC. So now I've built this up on a breadboard. And when I built this up, I didn't actually have a 330 ohms resistor, so I just put 100 ohms on there, and that will work just fine. So let's have a look on the breadboard and see how this works. So here's the schematic, and here's what I've built up on the breadboard. See, there's the 556 timer. I'm actually using a 7556, which is the CMOS version of the 556, but it works pretty much the same. It's got very few components, just resistor there, capacitors, some resistors there, another capacitor, and then there we have the pop meters. So let's go ahead and see if this works and what kind of sound this makes. So let's connect power. Well, that seems to work just fine, so I can go ahead and take the schematic. So I can go ahead and take the schematic now and start drawing it onto a piece of paper and see what I can come up with. Okay, so that circuit is what I will be drawing, and I've printed off a couple of these templates. Now these are 20 centimeters by 10 centimeters tall, so that is larger than what I'm actually going for. Actually, it's twice as large, or 4 times as large, depending on how you look at it. The reason for that is that it's easier for me to draw on this size rather than just go straight for the 5 by 10 centimeter size. So I will draw this on a larger size, and then I will scale that down later on. And I've also printed off a sheet with all these little dots, and they are just as a guide that I can use. Because obviously I need to have the right spacing, the right pitch for the 556 timer, as well as things like the potentiometers, because these need to be the right spacing, because these will be mounted directly onto the PCB. Obviously, you don't have to do that with potentiometers. You can get different kinds that don't plug into the PCB, but the ones that I've got, as you can see here, they've got the pins and they will fit right into a circuit board. So I'm gonna start with a blank sheet here, and this is actually not gonna be on the board itself, so I will be drawing on this just as an idea, just so I know like what's gonna go where, and if I do make any mistakes, then I can still change that on here, and then when I copy it over to the final sheet, then I know that's right. I will use one of these sheets for the silkscreen. I will also use one sheet for the copper layer. I think I only need 2 sheets, so just the one silkscreen and the one copper layer, and that should be enough. So let's get started, and I will start by marking out where all these components go that have to have the right pitch. So the 2 potentiometers, which I think I will just mount, like if this is the circuit board, I'll mount them on the side so you can adjust the pots like this. And then obviously the timer itself, that will go roughly in the middle, I would say. And let's see, because if I get my schematic here, so one potentiometer here is connected to one side of the 556, and the other potentiometer is connected to the other side. So it would make sense if I want to have one on the left side of the circuit board, and the other one on the right side of the circuit board, to orient this chip so that's it's pretty much facing towards where that potentiometer is going to go. But now obviously I'm not bound by having to put the chip on that center or straight or whatever. I can just make it a little bit, give it a bit of an angle, and that's what I will do. Let's see if think I want to have it something like this. So let's just, I will mark out where the pins are gonna go. And I'm not actually really bothered about drawing the pads or drawing the pins properly on these templates, because I will just import a pad into Kicad, so I can overlay that exactly where it's supposed to go, so that at least the holes will be drilled properly, and I should be able to mount all my components in as they are supposed to go. So we'll just start off by marking these pins for the 556 timer, and then 7 on the other side. And just so I know what's what, I will draw in, so I know that that is pin 1. And the next thing I want to draw in are the 2 potentiometers. Like I said, I want to have them on the sides of the circuit board. So those I will line up pretty well. Now let's see. I've actually measured out, it should be about 1 centimeter from the edge of the board. Pin there, 1 pin there, and 1 there. And the same on the other side. And then now I have got a 556 timer in the middle, and I've got pins marked out for the potentiometers on each side. So I will also draw that in just so I know what's going to go where. Just like that. And now I can just go ahead and follow the schematic and draw in all the pins and where everything's going to go. So I've got pin 1 connected to potentiometer, it's connected to 1K resistor, something like that, I suppose. This one's going to go around, and pin 2 and 6 are connected. So pin 3 and pin 11 have no connection on the schematic, but instead of just not connecting them at all, what I will do is I'll just take that off the chip and just add in a connecting point for it, because it might be useful for any sort of future expansions. If you want to have access to that pin, it makes sense to just have a connection point for it. So just look here, there is the pin, and then I can just put in a connection point. I can put it right there actually, so I'll put that there, and I will do the same on pin 11, which is actually going to be, it's not quite where I want it to be. Ideally I want to move it out a little bit further, which I can do if I just move these a little bit further out. So that's going to go there, and then that is going to go there, and then right that's actually already where I want it to be. So like that. And I will actually take that underneath that resistor there, so I've got that's going to be the output, and that will also be a resistor to ground, and then that can actually connect to both there, just like that. That should work fine, and this is going to ground. Okay, now let's see, what have I missed anything? That's pin 9, 13 and 14. Yeah, so that's what that will look like. Okay, so now I'm gonna line this one up just like that. So now I can draw the copper layer. So I know what's going to go where. So there's a pin, there's a pin, there's a pin. So this is where we will actually be drawing the traces. It's pretty straightforward. I'm just following what I've done on the other template. Like that, okay. That will do. Now I'm fairly confident that these traces will be thick enough, but just in case, we'll just make these traces a little bit thicker, and I'm just using an extra piece of paper under there. And let's use a marker for the 9 volts, because that will be nice and thick. This connection doesn't really matter, because only really goes to the wiper of the pot there, but I might as well. And there we go, that looks pretty good for a copper layer. Okay, there we go. So now I can take my next template and I can draw the silk screen on here. Okay, and here you can see I have scanned these images in, and you can see that they line up pretty well. So this is just the layer where I drew everything on, just to see where all the pins go and where all the components go. This will not be in the final project, but I will need it just to get all these locations for the pins. And then here is the copper layer, and you can see where I've got all my marks to make sure everything's lined up. that lines up pretty well with the other layer. It's not perfect, but it will be good enough. And then this is the silkscreen layer. Again, you can see all the marks line up pretty well. And I will just go ahead and save these as individual images. And then I can import them into Kicad. We go to the bitmap to component converter, where we can load our image. And it can come up with this error, and I have no idea what that's for, but you know. So resolution set to 600 by 600, and that will give me a size of 200 by 100. That's not right, so I need to set that at 1200 dpi. Yeah, so then we get a size of 100 by 49 millimeters. And then I can select down here the board layer where this is going to go onto. So for this I can use the silkscreen, the solder mask, or one or two user layers. Because this image we're not going to be using, I will just use the user layer. So with all the size and everything set this to PCB new file and export that. And you need to export that to a footprint library, or to a library. So I've got a library where I can just easily save it in there, and then I can go back to Kicad and I can open my PCB layout editor, which will bring up this window, and then I can just go ahead, add a footprint. So just search for it there and it'll just show up like that, and just paste it in anywhere I want it. And now I can use this to start placing my pads. And actually, before I do that, I just save this, and I want to import the other two images as well. So let's go ahead and close that, go back to the bitmap to component converter, load the new bitmap. I'm going to use this one because that's the silkscreen layer. Change the DPI back to 1200 so the size is correct. Check my black and white picture, make sure everything is readable. Yeah, I think this one will do. Now this is of course the silkscreen, so I can just select the board layer silkscreen right here. So I export that. I can go back to the layout here. And I just search for it, and there it'll come up as a silkscreen layer. So there we go. So there, now I've got the silkscreen layer. This one will not be used. Okay, so that is pretty easy so far. But now how are we going to get our copper layer on here? Because that is where the next problem lies. We go to the bitmap to component converter. You can see the board layer. I don't have a copper layer here, so I can load my bitmap in here, and that will give me the full file. So that all looks good. It's ready to be imported, but I don't have a copper layer. So what I'm going to do, I'm just going to put that on a user layer and export it. Then what I'm going to do, I'm going to find that file here in the just on my hard drive, and I can open that with text editor. And you can see it's it looks like a mess really, but if I just it just looks like a whole bunch of numbers, and well, that's really what it is. So this file just can be imported into a Kicad like this, and it will read all these coordinates, and then it will make the shape for you, and it'll even tell you what layer it's going to put it on. It's going to put it on the user layer. Now this is where the magic happens, because I can say like I don't want it on the user layer. So I will search for all instances of user. I'll take replace there, and I'm going to replace that for f.cu. So f.cu, that means the copper layer, cu on the front. Now replace all, and that has replaced every single instance of eco1 user, like right here, layer f.cu. So now if I import this into Kicad, it's going to look at this and see like, right, so these are all numbers, so that's going to be an outline for whatever components, and it's going to place it on layer f.cu on the copper layer. So I'll save that, and then I'm going to go back into Kicad, import footprint, and here we have it. So that is now on the copper layer, and that's exactly where I want it. So with that in place, I can now go ahead and turn these off for now because I don't need them. I'm going to zoom in on here, and I'm going to place all the pads. Now, easy way to do that. Just go here to the add footprints. I search for pad, and I can get all these different solder pads. This one has 2 solder pads. You can get 3 or 4. I don't want it, I just want a single one. And a 0.8 millimeter hole in the middle. And that is pretty good, so I can import that. It'll come up like that. Now I can do that, but you can see I can't really place that pad exactly there where I want it. What I need to do for that is change my grid size, and actually going to put it on 0.0025 millimeters, and that will give me a lot of control. As you can see, I can place this pad pretty much anywhere I want it now. So with that selected, I copy that, and then I can just paste pads wherever I need one. So one here. Alright, so I'm gonna go and do that for every single pad on the board. So I think that's it. Let's switch this copper layer on so I can see if everything is connected, and it looks like I'm missing one here. There we go. Yeah, I think that's all the components connected. Obviously we have single pads like this that are just connected to ground, and I will have to add that in as well. Normally I would just go and click on the pad, edit the pad, and then in the net I would just say, right, that should be ground, but I cannot add a net there. So I need to import the net. Now luckily I do have this board laid out, so I have got the schematic here. So I will need to use this to generate a net. There we go, and then I can open that in here. Now, of course, if I import netlist, I've got footprints for a lot of these. I'm missing a few, but that's fine. There we go. So it's going to add in all these components, and I don't want them. I only need netlist for the names, so I can go ahead and delete that. And then I can select that pad, and I can put that on the ground. So now that one is automatically connected to ground. And I'm going to add a filled zone. It should just be, let's change the grid back to 1 millimeter. And then I can say, right, I want that to be a ground plane. So select ground. So yeah, so it's created all these nice little lines on all the ground pads. Yeah, that should be alright. So now I've got 4 mounting holes. And I've got everything else set up properly, exactly the way it should be. Obviously I will need to rebuild this, but there we go. And so I'm quite happy with that. Now I can go ahead and plot this to Gerber files, and I can go ahead and order this board. Okay, well that's looking good. So I'm ready to go and send that off to the manufacturer, which is based in China. So it'll take a little while for it to get back here. So now we wait. And there they are. So yeah, they've arrived and looking pretty good actually. The only thing now left to do is to make sure that everything fits and start soldering this up. First of all, I made them as a panel, so I've got 2 here and I only need 1. So let's just go ahead and snap that in half. And here's a little bit of a problem. When I made this, the holes that I put in are 0.8 millimeters. Well, the problem with that is that the pop meters and actually the audio jack need bigger holes, so this doesn't fit. Now the pop meters you could technically just wire in, but it's going to be a little bit difficult to do the same thing with the audio jack. So what I'd really need to do is just get a drill and just make these holes a little bit bigger. The problem with that is that then I will lose the plated through holes, because obviously these are plated through holes. And that's going to be a little bit of a problem if I'm going to drill that. But I've got plenty of these boards, so I can give that a go anyway. So let's see what I can do with that. Yeah, that's getting that in there. The question is, if I solder this up, is it still going to work or not? We will see when I've done the other side and when I've done the audio outputs. Yeah, I suppose that fits in there. It's not ideal, but it'll work. Obviously, There's some extra pins in there that are just plastic, but there's no holes for them on the circuit board, so yeah, not great, but see if that will work or not. So let's go ahead and start getting the soldering iron ready. Okay, let's start with the resistors. This is 1K. What I could do is just solder it on this side, because this should still have a connection. I'm wondering if the plated through hole is gone, but if I solder it on the other side, that shouldn't matter as much, except maybe there's a ground pin here. Yeah, you know what, I'm just gonna try that. So I'm gonna solder this all in on this side rather than the other side. So it's gonna be 1K. Where is my solder? Right, now for these meters, so let's see if I can put them in like that. In this case, it doesn't matter which way up they go. I'll just do it like that. Now let's see if that's still solders to the pad. Okay, well that still seems to be on there. Yeah. The other one on the other side. Okay, well that's them in. And I suppose that will work. And now for this audio jack. Yeah, it's not great. It doesn't really like that. The pads have become a bit small. Well, let's leave it like that, see if it works or not. And then of course I need the 556 chip in there. This has to be soldered on the top because that is laid out like that for a reason. Very good. Right, there we have it. That's all the components soldered into that. So let's go ahead and get the chip. There we go. And then make sure I've got them up the right way around. Very important when putting the chips in. There we go. Now that's everything in there. Let's connect up my speaker.
Battery 80%.
And get myself a 9-volt battery and see if this works. Not hearing anything yet.
Battery 80%.
Let me go and see if I can troubleshoot this. Yeah, I think that's the problem. Yeah, I was afraid about that. So obviously, because I've lost my through hole there, this is no longer connected to ground. So I can fix that. I just need a little bit of a bodge wire. So what I will do is I just need to connect this ground pin up to any ground. And I'm going to guess that one right there will do. Let's just strip that. Connect that there. Okay, and now let's see if that has done the trick. So let's power that back up.
Battery 80%.
That's promising. Well, that works great. I'm actually quite surprised how little I needed to do to just make that work, but obviously few mistakes were made. I was able to rectify them, so it doesn't look quite as I was imagining it. If you look at it now, all the components on one side, they just look a little bit like someone just threw them on there. And if you look on the other side, well, that's what the design is. So now the question is, hand drawing a circuit board, put all the traces on there, all the components, is it worth it? I'd say no. At the moment, no, don't do it. It's not a great idea. I mean, you can do it, but if you do it, clean up all your tracks. I actually got, when I sent this off, I got an email from JLC PCB where I had these printed, because they had examined the copper layer and they thought there were loads of issues with it because it just doesn't look like a proper copper layer and it looks like there's all sorts of things wrong with it. But you can make it work. This is a LED, a light panel that I've made. It's got 44 LEDs on it. And if I just hook that up to 9-volt power, you can see that works perfectly fine. And there were no issues with this during manufacturing. But I didn't hand draw these. I actually made these traces in Blender. So in a 3D program, and that just gave me much more control over the thickness of the traces and exactly where I wanted them to go and make sure my clearances were right. things that you can't really do when you're hand drawing it. And the whole ground plane on this board as well I made in GIMP, so I just took the image that I got from Blender and I just filled in the whole ground plane, and that works perfectly. There's absolutely nothing wrong with that. Obviously, if you are going to do it, be very careful about your hole sizes. Make sure you read the data sheets for your components, which is what I didn't really do. So if you've got a pop meter, that doesn't fit in an 0.8mm hole. So that's something to be aware of. Other than that, I would say don't hand draw it. Don't do it. It's just not worth it. It was a very nice experiment for me to do and see how it would work, how it could work. I'm happy with the fact that it is working, but I probably wouldn't do it again, just because of the issues that I had with it. Anyway, that's it for this episode. I do want to tell you that this episode was sponsored by this breadboard. I actually made this myself. It's fantastic. It's a prototyping board, but it's the outline of a breadboard, and it's fantastic because if you've got your Atari Punk Console built up on your breadboard and you got it working on there, well, you can just copy it over onto this board and you got no problems. It'll just work because you've got it working on your breadboard. This is the same layout, so it'll just work like that. The reason I'm bringing this up is that I am selling these on my eBay page. So if you're interested in prototyping and using one of these boards, have a look in the description where you can find the link where you can buy these boards. Well, that's it for this episode. Thank you for watching. I hope you've enjoyed. If you did, do like, subscribe and share with your friends. Again, thanks for watching, and I will see you again next time.